Lesson 6G, projectile motion, object shot out at an inclined angle. Our example is from last lesson. A cannonball shot out of an angle of 40 degrees with an initial velocity of 70 meters per second. Here is the image labeled with its angle and initial velocity. We can list our givens, the velocity initial and the angle theta. Our known is the acceleration due to gravity being negative 9.8 meters per second squared. Using the cosine ratio, we can determine that the x component of the initial velocity is 54 meters per second. Using the sine ratio, the y component is calculated to be 45 meters per second. Now we know that the cannonball path will not be a straight line, rather a curve similar to a parabola, as an unequal force called gravity will be acting on it. Now under ideal conditions, the only component of velocity that should change is the y component. X will remain a constant during the entire trip of the cannonball. Question number 1. What is the velocity of the cannonball at the peak of its height? Assume ideal conditions from now on. Remember, the x component will not change, it's a constant. The y component, on the other hand, will change at a rate of negative 9.8 meters per second squared until it returns back to the ground. However, we can logically state that the y component velocity will change from positive 45 meters per second until 0 meters per second, where it stops rising and begins to fall. At the peak of the trajectory, the vertical velocity will now be 0 meters per second, while the horizontal will remain 54 meters per second to the right. So the velocity at the top is the sum of the vertical and horizontal components, which makes it simply 54 meters per second to the right. Question number 2. How high does the cannonball reach at the peak of its travel? Here are givens, knowns, and calculated values. Which equation will give us height or vertical displacement? Most of them need time, which we do not have, so equation 4 looks like our pick. Vf squared equals Vi squared plus 2AD. Sub in our values. Velocity final is 0 at the top. Our initial velocity is 45 meters per second and acceleration is gravity. Square 45, double 9.8, move the 2025 and isolate d. Divide negative 2025 with negative 19.6 and our displacement is positive 103.3 meters. The displacement in the y plane will be 103.3 meters. Question number 3. How long does the cannonball take to reach the peak of its height? Here are givens, knowns, and calculated values. Which formula shall we choose? Looks like we can use equation 1, 2, or 3, but equation 3 will need the quadratic formula, so it's between 1 and 2. Let's use equation number 1. D equals Vi plus Vf over 2 times delta t. Plug in our values, solve for t, and we get time is 4.59 seconds. Question number 4. How long does it take for the cannonball to strike the castle at the same level that the cannonball left the cannon at? Well, here are givens, knowns, and calculated values. We include the time that we calculated for the ball to rise to the top. T equals 4.59 seconds. Now, logically, if we assume that gravity is a constant, then the time up will equal the time down. Total time of the trip will be double the time up, making our total time 9.18 seconds. We can also solve the problem using one of the 4 equations. We'll calculate the time it takes for the ball to arrive from the peak back down to the ground, and then add the 2 times together. Which equation shall we use? We can use equation 1 or 2. 3 requires final velocity, which we assume to be negative 45 meters per second, but we have not yet calculated it. And equation 4 does not solve for time. Let's use equation number 2. D equals Vi t plus 1/2 at squared. Plug in our values. Note how V initial is the velocity at the top, which is 0 meters per second. This leaves us with negative 103.3 equals negative 4.9 times t squared. T squared equals 21.08. Time down is 4.59 seconds, which is the same amount of time it took for the cannonball to arrive at the peak. So total time up plus total time down will make 9.18 seconds. Question number 5. How far away is the castle? Here are givens, knowns, and calculated values. We'll use our horizontal velocity to determine how far it moves sideways and the time it took to rise and fall. Which equation shall we use? Which formula will provide us with horizontal displacement? All but the last equation will allow us to use the horizontal velocity to find horizontal displacement. We use equation number 3 since it has yet to be chosen. Displacement in the x equals velocity final in the x times time, minus 1/2 acceleration in x times t squared. Note how acceleration is 0. That makes the second term equal 0. Displacement in the x equals 54 times 9.18. Displacement in the x is 495.72 meters. We'll round that to plus 496 meters. Question number 6. What is the velocity of the cannonball as it strikes the castle? Remember, we need a magnitude as well as direction in this answer. Here are givens, knowns, and calculated values. We know that the horizontal component of the final velocity is 54 meters per second to the right. we need to calculate the vertical component of the final velocity. Common sense says it should be negative 45 meters per second since gravity is a constant, but we will confirm it using calculations. Which equation shall we use? It looks like we should be able to use 1, 3, or 4. We'll use equation number 3. D equals velocity final in the y times t minus 1/2 at squared. Plug in our values. Multiply 1/2 negative 9.8 and 4.9 squared. Remove the brackets. Isolate v final in the y. Divide negative 220.949 with 4.5. We find velocity final in the y is negative 45 meters per second, which is the same speed as the velocity initial in the y. Velocity final is the sum of the final x and y velocity components. We'll use Pythagoras' theorem and calculate that v final and that v final is 70.3 meters per second. Rounded to 70 meters per second, this makes our initial speed the same as our final speed. Direction can be calculated using any of the 3 trig ratios. We will try the tangent ratio. Tangent theta equals opposite divided by adjacent. Tangent theta equals negative 45 divided by 54. Theta equals 40 degrees. The velocity of the cannonball is 70 meters per second, 40 degrees downwards relative to the horizontal.